Hi guys, and welcome back. So the last step in our cluster upgrade process is to bring our worker nodes up to the inline version with our Kubernetes master nodes. So in order to do that, we're going to need to make sure that we update the kubelet service that's running on each of these worker nodes so that the kubelet can basically communicate with the latest version of the Kubernetes master node that we've installed. Now, with the worker nodes, if you think about what's happening on the worker nodes, they're actually running pods, right? When we set up our cluster and we added those two worker nodes in, we actually created a deployment controller, and we told that deployment controller that we wanted 4 replicas of the Nginx pod to run on our cluster. And so what we found out is that we had 2 pods scheduled on worker 01 and 2 pods scheduled on worker 02. And so when we take worker 1 and upgrade it, we want to actually take it temporarily offline for maintenance in a controlled fashion so that we don't kind of rug pull or pull the rug out from underneath Kubernetes and confuse it in terms of what's happening. Because if we just took that node offline, according to Kubernetes, it would think that that node is just gone and it would take the appropriate action. However, we can actually plan for that in advance by doing something known as draining the node. So that'll basically take the node offline in a controlled fashion so that we're not pulling the rug out from underneath Kubernetes. So let's go ahead and get the worker nodes in our cluster upgraded here. And so the first thing that we're going to do is run kubectl drain on the first worker node. Let's go ahead and run this. So we'll say kubectl drain. And of course, I'm running this from my master node because that's where I have kubectl configured to communicate with the API server. So we'll do kubectl drain and we'll say worker 01. And you're going to see that we get this message saying it can't delete the daemon set managed pods. And that is because we have, I think it's core DNS, or not core DNS, but Calico. So if I do kubectl namespace kube system get all, we should see that we have these daemon sets here. And so basically this is spinning up a pod for Calico as well as kube proxy on all of the nodes in our cluster. So the reason we have 3 of each is because there's 3 nodes in each, three nodes in our cluster. And so it needs to spin up a Calico node on each, the master and the 2 workers. And the same thing for kube proxy, 1 on the master and 1 on each of the 2 workers. So if we were to add more nodes into our cluster, the daemon set is going to ensure that whatever node or whatever pod is configured in there is going to run on at least once on every node within the cluster. So we need to add in this flag when we do a drain, say ignore daemon sets. All right, so that's basically going to take it offline. It's going to say, I don't care that Calico or kube proxy are running on there. I just want to take it offline anyway. And so what you're going to see happen here is that the pods that were scheduled on worker 01 are being evicted. And so evicted is basically the term that Kubernetes uses to indicate that this node is being taken offline. And so therefore these pods, it's basically telling the scheduler that these pods can no longer run on this particular node. They need to be rescheduled somewhere else on the cluster. And then once that's completed, including core DNS for that matter, you'll see that node worker 01 has been evicted. So it's ready, and we can go ahead and do kubectl get node. And you can see that it now has this attribute here under status that says scheduling disabled because we have cordoned it off. We have drained it, and we've basically told Kubernetes that we do not want pods to be scheduled on there. So now if I did a kubectl describe pod on our 4 Nginx pods, what you're going to see here is that the first one is on worker 02, the next one is on worker 02, and the third one is on worker 02, and the fourth one is on worker 02. So what happened here is it took the 2 pods that were previously scheduled on worker 01, and because we evicted them, it now scheduled them, the Kubernetes scheduler scheduled them onto worker 02. So right now in our cluster here, worker 02 is taking the entire workload that was previously distributed across worker 01 and worker 02. So now that worker 01 is offline, and there are no pods scheduled on it, we can go ahead and upgrade the kubelet on this node. So what I'm going to do is just do an apt get install kubelet and then we're going to mark the specific version that we want. So 1.22.7-00. And if we run that, you can see that it's going to go ahead and upgrade the kubelet service here. And so it's installing 1.22.7 on top of 1.21.4. That's kind of what we expected to happen, right? So now that we've done that, we can go ahead and come back over here. We can say kubectl get node on our master node. Let me clean up the terminal there. And now you can see that the worker 01, as soon as we upgraded the kubelet, it's now reporting in that it has a newer version here. So only worker 02 has the older version of the kubelet running on it. So now what we can do is actually bring the worker 01 back online, and then we can drain worker 02. So essentially what we're doing is gracefully migrating the pods all over from worker 02 all over to worker 01. So let's go ahead and do that now. I'm going to switch over to my documentation here, and we're going to go ahead and run uncorden. And this is going to basically restore the functionality of worker 01. We'll say kubectl uncorden, and then we specify the worker name, worker 01, and it says uncordoned. So now if we do kubectl get node again, you can see that that scheduling disabled attribute no longer appears on worker 01. So now worker 01 is ready to take some work. So what we can do is gracefully drain worker 02, and we're going to do that using the same commands that we used before, only we're going to change the name of the node to worker 02. And of course, we want to make sure that we ignore the daemon sets there. And you can see that all 4 of the Nginx pods that were running on worker 02 are going to get evicted, and all of those will end up getting rescheduled over onto worker 01. Awesome. So all these pods have gotten evicted. So we've got all the Nginx pods. We've got the core DNS pod. We also have the, well, actually that's everything. So we had 5 pods total, including core DNS. And so now if we run kubectl get node, we should see that worker 02 has now changed into scheduling disabled. And if we do a describe on our pods and look through the scheduled nodes, you can actually see that worker 01 has taken over for all of the pods. So the Kubernetes scheduler component has basically said worker 02 is offline. So hey, guess what, worker 01, you have to take on all of the work. So now we're at a point where we can go ahead and log into worker 02 here. We're going to do an apt-get install on kubelet and say version 1.22.7-00-yes. And we'll go ahead and get that kubelet service upgraded. And once that's upgraded, it should come back online, and then we can uncorden the second worker node and rebalance everything in our application across both worker nodes once they've been upgraded. I'm also going to go ahead and do, as a best practice, apt mark. We're going to say apt mark hold on kubelet, so that that package does not accidentally get upgraded by the apt package manager. And we're going to do the same thing on worker 01 here. So now we've locked the versions of all the components on the master node, worker 01 and worker 02. So if we do an apt upgrade on any of these nodes, we're not going to accidentally upgrade our Kubernetes components and potentially break our cluster. That would be bad. So let's go ahead and come back to our worker node, or our master node. And we're going to run kubectl, and we'll say uncorden, and we're going to uncorden worker 02. So worker 02 has now been uncordoned, and we can go ahead and run kubectl get node, and you can see that both nodes no longer have scheduling disabled under the status here. So now we could do, if we wanted to rebalance our pods, because I don't think that the scheduler is going to automatically do that for us. You can see that all these pods are still running on worker 01 when we do a describe. So if we wanted to force a rebalance, what we could do is do a kubectl, and then I think we want to use a rollout command. So we'll do rollout, say kubectl rollout, and this will basically help us to manage the deployment controller. As you can see, we can use the rollout commands to manage deployments, daemon sets, and stateful sets. So what we'll do is basically just restart a rollout on our deployment controller. So we'll say kubectl rollout restart, and then we'll specify the name deployment / my nginx deployment. I think that's what we called it. Yep, sure enough, there it is. And then we're going to go ahead and do another describe pod. And let's see, we've got worker 01, we've got worker 02. All right, good. So we've already got 1 on each. Worker 02, so that's 2 on number 2. And worker 01, so that's 2 on number 1. So by using that rollout command, we've effectively told the scheduler that we want to rebalance everything for this nginx application that we've deployed by using a deployment controller on our cluster. And now that everything has been upgraded, if we do kubectl get node, we're now successfully upgraded from 1.21.4 all the way up to 1.22.7. We could follow a similar process as well if we wanted to upgrade this Kubernetes cluster all the way up to the latest version of 1.23. Whatever the latest patch version is. I think it might be 5. Of course, we could use apt cache Madison on kubeadm to get that information. But basically, you just want to make sure that, again, you're not skipping any minor versions. And so, yeah, it looks like 1.23.4 is actually going to be the latest version. So we could kind of replicate the entire process that we just did, where we started with the master node. We got the kubeadm upgraded. We ran the kubeadm upgrade process. We upgrade the kubelet on the master node. Then we upgrade all of our other master nodes, which in this case we didn't have. And then, and only then, can we go and actually upgrade the kubelet service on each of our worker nodes. So knowing this upgrade process, knowing how to use kubeadm, understanding the upgrade process for a Kubernetes cluster that is managed by kubeadm is an important topic that you will need to know for the Certified Kubernetes Administrator exam. So I hope this has been informative for you, and I'd like to thank you for viewing.